very excited to talk to Aurimas. I met him a few times before we even had Gradle Enterprise at the Gradle Summit. He was working on the Android SDK team, and happy to have him here and kind of share his developer productivity journey. Daz was very hands-on with helping him throughout the way, so excited to have Daz on board here as well to dive in through some of the technical stuff. So let's get going. Aurimas, why don't you start with just a quick intro about yourself and about your project and kind of what brought you to us?
Sure, yeah. My name is Aurimas. I work at Google, working on AndroidX libraries. Folks who work on Android most necessarily have to use some of the things I've helped ship. So I'm one of the people kind of making sure that the ship sails smoothly in our land. And so, our team works on a lot of libraries. We have, 300 plus Android and Java libraries that we ship. And my team is kind of responsible for making sure that it builds, tests, and is tracked properly and all whatnot. And then that ends up being a lot of kind of Gradle work to make it work, to make it happen. And the way we kind of ended up working together with Gradle on Gradle Enterprise was that we also have our project in two places. We have it in AOSP, which is Android open source project. And then we also have a mirror of it in GitHub. And to make our GitHub project easier to contribute to and make it have a better CI setup, we essentially have a way to work with Gradle to kind of make it a better experience. This is where we kind of landed. And then kind of explaining a little bit about our project. Obviously we take contributions. We'd love for you to kind of come in and help us. But we don't have all of our projects building from GitHub. We have some projects that kind of require some additional bits and pieces that you can only get in our AOSP setup. So we kind of have an interesting setup, like an unusual setup that Gradle Enterprise actually fits in pretty well to do. So the way our GitHub project works, we actually have, I believe, something like 12 projects that are individually, buildable and has its own settings.gradle files, which allows you to focus on just this one specific library or this other specific library, whereas our main project is more of a monorepo where you can just open all of it all at once. So that's kind of like the TLDR of me and the project that I work on.
Nice, great intro. Let's hop into the topics of discussion. Right, tell us a little bit more about how AndroidX runs builds and tests internally and externally. Whatever you can share, of course.
Sure. Yeah. So we essentially have a fair number of developers internally and a couple of people who are contributing to us externally. The way we do our builds is, entirely using Gradle. We use, AGP and a variety of other plugins that are out there that are available to everyone. Our setup is all entirely visible in the GitHub project. So if go deep diving in build source, you'll see all of the juicy bits of the things that we have in there. So that's the part there. We have, as I mentioned, over 300 projects. I believe it's like 500 something when you include all the test projects and whatnot. So it's a beefy project. It's probably one of the largest open source ones out there in the wild. So it was actually a worthy project to kind of benchmark to see how Gradle Enterprise, it would even work for something this large. So hopefully this will give you, some confidence that this is, a tool that works from, the smallest of projects to something like a behemoth that my team, works on. So the things that we do in GitHub, we end up, building, using Gradle, and we run tests using Gradle, and then Gradle Enterprise is now able to kind of show all of the results of it in a nice way to our developers and contributors. So I think that kind of throws some of the details in there of like what our build is like.
Yeah, absolutely. Thanks for that background and context. And as far as pain points and challenges that you said, hey, let's maybe try out Gradle Enterprise to see solve something. What were the major ones? What were the major, I guess, use cases and problems that you were facing that you're trying to solve?
Mm-hmm. That's a good question. I think there's a couple. I think when your project gets bigger and bigger, it becomes not really scalable to build it from scratch every time. So, I think most folks have probably felt the pain that, if you have to do a clean builds tend to be slower. And, as your project gets bigger and bigger, that becomes a bigger problem. So for us, that was definitely one of the things top of mind, that we didn't want to do, build everything from scratch. And, we try to use tools that are out there that are, help us, so GitHub Actions specifically provide a way to restore some of your project information from the previous build, which helps some, but you have to do kind of custom tweaking to make that work. And we wanted to kind of get even better results. So we actually even kind of invented our own tool called Affected Module Detector, which ended up shipping as a plugin. Dropbox kind of took the idea and they published a plugin that's out there that essentially allows you to selectively only run the tasks that are relevant to the files you've changed. So if you have a project of 300 different projects, you can just say, I touched this file, what tests should I run? And it will only run the tests that are relevant, which is a great tool, but it still doesn't get you to the full kind of maximum amount of not rerunning things, because it will still rerun, every time, even if someone has already ran exact same, configuration of files. So that was definitely one of the things. And then I think the other angle that I think it helps us internally, especially, is, it happened on my machine, right? I feel like that's an anecdote that anyone on DevX has probably felt, is like, it failed only in my machine and it doesn't on mine. And how do we go about, figuring out what went wrong? And build scans, when we can enable our local developers uploading scans, we can be like, oh, this is exactly what happened. So instead of me trying to guess, like, are they using Mac? Are they using Linux? How many cores do they have? Which version of Java they're running? All of that stuff just gets uploaded, and then we're able to pull all that information and then, go and debug with much richer information, rather than, doing a meeting with someone and trying to, walk them through the steps of like, how do you give me enough information to debug, what's going on in your machine. So those, I think, the two big ones.
And do you even get too many of those for external contributors? I mean, that's one thing that makes, our discussion with you unique, right? Most of our customers are, using it for themselves on premise, right? And you're trying to enable it. In addition to other use cases, you're trying to enable the community to say, hey, come and contribute to this thing. It's more efficient. You have build scans for debugging and whatnot. Dude, when external folks hit those kind of issues, do they even reach out? I mean, I'm just curious there. Or do they just stop contributing eventually? And how do you maybe monitor that? Sorry for going off script a little bit, but that just popped up in my head.
No, it makes sense. That's a good question. Yeah. So today, external contributors, while our Gradle Enterprise instance is public and everything is visible, not everyone can publish to it. Obviously, that's for security reasons. We don't want people to, try to do creative things to take it down. So we actually don't allow external folks to upload it except for viewing the scans. So the answer is no from external people. We don't get that just for that reason. But we do internally use it quite a lot. And if you poke around at our instance, you will definitely see variety of things that people kind of uploading as they work, and then the kind of problems they hit. And kind of top that off, I think the one thing that is helpful for us especially is you can actually even view trends of what are the type of tasks that are failing. So it gives us ability to see for our local developers what kind of problems are they hitting.
Yeah. Just to clarify, if an external contributor submits a pull request, then we do get build scans for their contributions. That's right, isn't it?
Not today, no. Due to the reasons of how GitHub Actions work and security works, we cannot do that today.
Got it. Yeah.
Something to investigate for sure.
Yeah. Once it's merged, we get scans for it.
Yes.
Yeah.
All right. And for the audience, right, you can use this QR code to get to the AndroidX project on GitHub. There's a link that Justin put in the chat as well. And their Gradle Enterprise instance is also live, and anybody can go in and take a look around. So when you started this process, Aurimas, one of the first things that you all did was to set up, of course, build scans, and what kind of things, I guess, were you tagging, and then maybe start there, or maybe you want to even share your screen and show us kind of how this is live.
Sure. Yeah. Let me get kind of like from a little bit from the beginning. So I think the one bit to kind of mention is that initially when we started, we didn't jump to Gradle Enterprise as the first solution to our problem. We kind of wanted to just explore, what would we even get out of Gradle Enterprise? And one nice thing is that Gradle has a public instance where you can actually upload scans. So if you run in any project anywhere, any task, and then you attach -- scan, it will, and then of course you have to go through a license agreement and make sure that you are okay with what happens to your information, because it uploads to Gradle servers. But the nice thing is essentially allows you to try out Gradle Enterprise before you kind of like buy in and see what you would get out of it. You don't get all of the features, but you get kind of like the more interesting single build analysis that you might want. And so that's exactly how we actually started. So we had issues where, some tasks are rerunning in a funny way, or we want to like do a little bit of analysis on like some very specific thing. We're kind of like uploading and doing that. So that was kind of like our inception of like kind of like thinking, getting a taste of what the Gradle Enterprise would be like. And it was very, helpful. And obviously that kind of led to us, being more excited about trying it out. And then I think kind of one step after what we ended up doing is we actually set up a Gradle Remote Cache Node, which is a thing that you can kind of just set up yourself without using Gradle Enterprise, which only does the caching. You don't get any of the nice analysis or any kind of, evaluation, but it speeds up your builds. And Gradle Enterprise by default comes with these cache nodes set up. So if you want to try the whole thing, that's, the easiest option, but you can also do the manual step of, setting up the remote cache. So that's kind of some of the background. So I think the next thing we could probably jump in and just kind of like show you a little bit of what the experience is like on using these. So I will start on a screen that probably most of you who use GitHub are familiar with, which is GitHub Actions screen, where you go and you see a bunch of your projects and a bunch of tasks that run. And in our case, as I mentioned, we have a variety of different projects, and this is, while it works, it's not always the best screen in terms of like kind of figuring out what's going on. And what I mean by it, if I want to go and figure out what exactly went wrong with the build, I have to go through a variety of logs. You have to scroll through and hopefully in this, gray and black screen, notice what actually went wrong, which, I've squinted at these long enough that I will find the failures. But now we have Gradle build scans, which actually allows us to jump in and actually see what went wrong. And it actually does a lot better job of pulling out exactly what the problem was. So, if I go and click on what the failure is, this is, extracting all the bits and pieces of the things that are actually relevant to my problem, as opposed to, kind of like fishing through the GitHub Actions UI. And to make it even nicer, given that we have dozens and dozens of projects, one thing is actually, it's sometimes hard to view if like multiple projects are failing at the same time. So what Daz and we kind of worked on is we created a way to view all of these things at once. So you're able to simply go to a URL that shows up at the top level of the GitHub action. And that like shows essentially the same UI we saw on the previous screen, all at once for the single CI run. And that lets you do, kind of like analysis. You can see the build times. You can kind of jump in any of the individual thing, and then you can jump to the same screen that I saw without kind of going through the logs. So it's kind of like a nice way to tie it together when you have, multiple things going on at a single GitHub action.
And for the folks in the audience, right, what Aurimas is showing here, this is kind of the Gradle Enterprise entry, list view where you see each row is a build with everything that's happening. And for the folks who aren't familiar with that.
Yep, that makes sense.
So, Daz, how you all did this is essentially those custom values, key value pairs, yeah?
That's right. So with Gradle Enterprise, you can configure your builds to add tags, links, and custom values, which is sort of a way to enhance the build scan with specific information about your build. And so what we did is we actually created some custom values, like basically the CI, the GitHub Actions run ID is a custom value on these build scans. And so really that link is just a link to the list view with that filter applied to say, show me all the ones with this particular custom value. And then we've actually configured, so I think Aurimas has highlighted at the top there some of the links. So you see the CI run is the one that's the CI, that's basically the ID from GitHub Actions, which we can use. And then we've also enhanced it with a bunch of links that Aurimas was just highlighting at the top of in the summary view that basically lets you view, show me all the other build scans for this same Git commit ID. Show me build scans for this that ever ran for this CI workflow. That's not so useful because there's a lot of them, but CI run build scans is effectively it's effectively the reverse link to get back to the GitHub Actions view. So yeah, you can basically customize these things. We provide a plugin called the Common Custom User Data Gradle plugin, which basically does a lot of the common things, gets Git integration and adds a bunch of standard tags, detects if you're running in IntelliJ or if you're running in Android Studio, things like that. So basically adds a bunch of custom tags and custom values. This means you don't have to do that customization. And these are things that haven't been built into the core Gradle Enterprise plugin, but are really common enhancements. So we sort of provide that as an open source project. And people sometimes fork that and add their own things to it as well. So, yeah.
Thanks for that, Daz. And Aurimas, just developer workflow wise, these have been helpful. I'm assuming from helping our other customers, right, is to kind of give developers everything that they need in one place. But specifically, what have you found helpful here, just workflow wise? What things have you noticed, and what can you share with the community as far as just to give other folks stuff to try? As Daz said, right, we don't come out with all of these out of the box, but I want the community to learn like what's possible, right? And so what can you share there that has been helpful with just improving the developer experience when stuff goes wrong?
Yeah, I mean it's a variety of things. I think there's a couple of things that I ended up like blogging about, and one of the examples was actually where we ended up finding that we had a really what's the right word? Excessive amount of network activity. I believe we have a slide on that. So let me stop. I don't know how do I even stop sharing the screen? I think maybe I have to close it. Oh, here, right, found it. So we'll have a slide if someone can put up the slide. Sadly, the build scan has disappeared because that happened like 6 months ago. So we no longer have the beautiful build scan. But if we could pull up the slides, we have one thing that shows that we're essentially doing an excessive amount of network activity. We're doing like an hour and 45 minutes of like fetching network stuff from the network. And that was the kind of thing that we're able to like spot in one of the build scans. And then we were like, well, what's going on? Like, let's debug it. Let's figure out what went wrong. And that's like an example of how we're able to, jump in and kind of like debug of what's going on. I think one thing that to note is CI is extremely, it's a black box, right? You don't really know what's going on in CI outside of what the logs you're getting out of it. And I think having and then even reading the logs is not a trivial job. Gradle prints out a lot of things, and obviously a lot of them are useful, but it's really hard to parse when you have thousands of lines of things. So like being able to spot that the downloads is happening from logs in GitHub Actions, you probably would never be able to do it easily. But with scans, you can poke in the network activity tab and you see like, oh, we spent an hour and 45 seconds fetching. And what happened in our case is we had our custom snapshot server that was supposed to serve some snapshots from one specific project, but we were going to it at the very first entry, and it was causing us to do getting a 404 from every single request from every single dependency we've ever had. And that was causing this extreme thing. And luckily, Gradle has built out APIs to say, like, from this artifact, only go and fetch this type of, Maven group. And that essentially made, our network go from, 1 hour and 45 seconds to drastically faster, which, if I will jump back to sharing, I can show you if that's okay. I'm gonna.
Well, that's exactly what I was going to ask next. Is how did you catch it?
How did I catch it? So yeah, like
how did you first notice it?
Yeah,
just
so
the
we
dependency downloads, I'm assuming.
The way
or was it in a build scan?
So we ended up looking at, why is our build slow, right? I feel like that's how a lot of people start. And, that just starts with like going to, androidx.dev and then just kind of looking at the duration of like, where is this time going? And that actually, made us think of like, this specific project, I want to focus on something, paging, playground, which is like one of our projects. I can go and see like, this one specific project, how much time are we taking? And this gives us like the general, wall clock time. But it also lets you jump into more specific things in here. And then one of the things here, we can actually highlight, how much time are we spending dependency downloading? And then, here it looks very nice and good because now we're down to, at the worst case, when everything is, nuked, it's 15 minutes, which is still fairly slow. It's probably something that we want to investigate a little bit more, but it's most likely like a nuclear option where everything is deleted and then we're fetching, gigabytes of information. So like kind of looking at a specific scan, you can kind of, jump in and investigate like what on earth is going on when you're going at network activity. And it tells you, like the kind of gets that were made, how much it was downloading and so on. And so this exact snapshot server is the thing that, was and ended up being used to download, Guava and downloading AGP and so on. And obviously the server doesn't have it. So we were just hitting a ton of 404s, which, was causing all sorts of slowness that, we wanted to work around and not hit. So that was kind of like, I think a really kind of like, good example of how you can kind of go from, a performance tab for a specific thing and to kind of dig in on various things, and you'll find different things from different parts, like maybe build cache has like a really high overhead for you. And that could be that maybe you have a task that is not worth caching. Like there's certain tasks that are really fast locally, but end up causing, a really slow network, request. Similarly, maybe your serial execution is, very slow. And that means, your just tasks in general are slow. And then you can kind of look, how much parallelization are you getting out of your project? So like, for example, for AndroidX on Github Actions, they only have 3 threads by default, the free version. So we're getting 1.9, on average of kind of serial execution, kind of speed up, which is, it's good. It's actually, fairly efficient for, given what we have. So it's a way to kind of like go from, 10,000 foot view, slowly kind of digging in deeper and deeper until you kind of like identify where the problem actually lies.
So you saw it in just that dependency downloading here, and then you went to the build scan and you noticed that the gets were just taking forever.
That's right. Yep.
Nice.
So yeah, that's what's happening for this specific case. Yeah.
Bruce, we had a couple of specific questions about the implementation. Maybe we could just dive into that are kind of direct. We had one. So in the end, in the workflows, did you end up using the Gradle Enterprise Cache Node or the GitHub Actions cache?
So the answer is both. And I think maybe I can let Daz jump in and explain the bits and pieces of how that all ties together.
Sure. Yeah. So what we're using is the Gradle build action or GitHub Actions, which is actually is something we developed for Gradle to help you run Gradle builds in GitHub Actions. GitHub Actions provides a coarse-grained cache to basically restore file system state between invocations, and we've leveraged that pretty heavily in our Gradle build action to basically try our best to restore your Gradle user home between builds. So this means that if you run a build the second time, you run a build, run one build, run another one with not many changes. Hopefully, it's just like running it on your machine as though you ran it straight after the previous build, even though it's running on a completely different node. Now, we can't restore everything because it just ends up being too big, but we do a lot, and so that's the GitHub Actions cache, using that restoring there. But we also use the remote build cache and the local build cache for Gradle. So the Gradle Enterprise Remote Build Cache and the Gradle Local Build Cache. One of the big benefits of the Remote Build Cache is it also works for me when I'm working at home as a developer. So when I was working on AndroidX, making pull requests, I just basically run the build and I get I get speed ups because, I haven't run for a couple of weeks, or it's been a week since I've done it. I then don't have to basically build everything from scratch because I can basically start with pull the latest stuff down from the main branch, run a build, and it could be pretty fast because it's getting everything from the remote build cache. So we use both there, and and I mean maybe I should. Oh, sorry, that's hopefully that answers the question.
I think that was a really good answer. I think that's exactly kind of what they were going for. Maybe one more. This one's kind of interesting too. I know that we have a couple in Q&A, but we'll get to them. I think we're gonna. But one more that's kind of interesting. I'm curious about this too. Are you considering? Is AndroidX considering using the Gradle version catalogs or bill of materials files to publish all of the AndroidX libraries that are like strongly related, so that it would be easy to keep track of the relationships and requirements between them?
Yeah, no, it's definitely a request we've gotten before. So it's heard. I think Gradle catalogs for a long time were an incubating feature. So we definitely didn't feel like that was the right solution for us. It just graduated to stable, I believe, in Gradle 7.4. So it is now stable, but I do feel like it's not quite the solution you would want for publishing a set of kind of like libraries to use together. So I think BOM probably fits the use case better. And we've looked into using BOMs. I think we're trying to figure out what would be in that BOM. Like we have a lot of libraries. Like would we want to include all of them? Would we want to include a subset? Do we want to have like multiple versions of BOM for like people who like, bleeding edge and they want to use the latest alphas of, AndroidX or Jetpack Compose and so on. So I think we're working on it. We are thinking like it's definitely something that, will happen at some point. I think like what shape will take will probably depend on like kind of iteration. Like we'll ship a couple of things and then see what the developer community feels like. And, we'll want to, kind of assess and adjust the plan according to that.
Awesome. Thank you. That's an interesting answer.
And there was another question, which kind of is a nice segue to the next topic. One person asked, "Hey, does this work with GitLab or Bitbucket?" And it works with Gradle Enterprise is not replacing your CI, right? We work with all CI tools and version control systems. And to segue into kind of the next topic, right? Was there anything specific, this for Daz and Aurimas, right, that you all had to do to get set up with GitHub Actions, right? We have a lot of folks asking like, hey, we want to explore GitHub Actions. How was that experience and workflow, and anything you can kind of add there?
Yeah, I'll jump in, I guess, for the kind of the basics. So like we did the initial setup of just GitHub Actions, which essentially like invoke Gradle, run things. And then we were kind of like trying to figure out the best way to kind of how to invoke Gradle. There are, a lot of things that come with it in a sense of, the stuff that Daz was talking about, like restoring things from GitHub Actions to kind of maximize your usage of it and so on. So I think we kind of did the initial setup there and it was, okay. Fairly good. And then we actually even adopted the V1 version of the Gradle GitHub Actions action. I don't know whatever the name of the actions are called. So we adopted the first version. And I think what that kind of spurred is, Daz was already working on the next version. And we were trying to see how would that dovetail and us being able to, just adopt it. And before I let Daz jump in and explain a little bit more, one thing to note is that the GitHub Actions part of the Gradle is open source and free, and you can just jump in. There's no, and it's nothing to do with enterprise. We just happened to kind of like set it all together at the same time, just because the same folks work on, a lot of related things there. So anyway, Daz, you can jump in and kind of explain a little bit more on that.
Yeah, sure. So yeah, it's a fairly recent, I wouldn't say it's recent development, but in the last 6 months, we've been working really hard on maximizing what we can get out of GitHub Actions, maximizing the way GitHub Actions and Gradle work together. So through this, what's called the Gradle build action. I'm sure we'll put a link to that somewhere. It's basically a github.com/Gradle/Gradle-build-action. And basically that's the way. It's the ideal way to run Gradle builds from within your GitHub Actions pipeline. Similarly to say Jenkins has a Gradle plugin to run Gradle builds from within Jenkins. And basically this action, what it does is it does a lot of things like it takes care of that Gradle user home save and restore between invocations. And it also has some Gradle Enterprise integration built in. So if you have a build scan link that's generated by your build, we'll automatically add that as a annotation to the top level GitHub Actions view, just so it's easier to find. So you have to scroll through the link through the logs. Now those links are not clickable. I'm going to need to work with GitHub Actions people because I've never been able to find a way to make them clickable, but they're there and it makes it a lot easier to get that the value from those things. And I do know that there's a lot of best practices that we sort of developed and kind of developed through this project. And I know Aurimas said, you should write a blog post about this. And it's definitely high on my list of priorities is to start documenting not just how to use the Gradle build action, but best practices and how to get started with it and things like that. So.
Yeah, that's I think that's right. We have more questions, or should we kind of carry on? I think we had some lessons we learned that might be interesting to show for folks.
And as one thing I wanted to add there was, you also with this Gradle plugin, the common custom user data plugin, right? You're also tagging builds so you can filter for them. We saw a few tags, like you had CI, you had. I guess you had operating system as well. What kind of stuff are you tagging, Aurimas? If you could just spend a kind of minute there, and how has that been useful for you all, other than just filtering down and finding all CI builds?
Yeah, I think in the custom tags bits, the ones that we've kind of found quite useful. I think one thing that it does for local developers, it actually tracks all of the files that have been modified in Git. Which actually gives us a good signal of is someone's local state clean? If they went ahead and modified some build.gradle files, obviously it's not going to be same results of what I would be seeing on my machine. So if someone goes and says everything is failing, and then they went and modified something in build source, then I can be squint, are you sure you meant to do this? Then it gives me a little bit of an idea of are they going from a clean state? Are they doing something custom and they're, kind of shooting themselves in the foot? It gives me, a lot of that kind of information there.
And I guess we can move on to kind of the next topic. So you got Gradle Enterprise set up. You're tagging your builds. You're connected to all the projects and whatnot. And the next step was, hey, what can we, and you found that dependency download issue and you all fixed that. And the next step was, hey, what else is kind of slowing down our build? And Daz and the Gradle Enterprise Solutions Engineering team, they've developed these nice experiments that show these bottlenecks and whatnot. Daz, you want to briefly talk about that? Then we're going to kind of run into some of the wins and findings that came out of those.
Yeah. So it was really nice because as a solutions engineer at Gradle, one of my key roles is to when new customers come on board, we basically have this proof of concept phase where we say, okay, let's connect your build to build scans, just start publishing. Now let's look at what we can optimize. And so we basically look at the build scans before, and we spend this trial process optimizing your build using Gradle Enterprise. So during that process, you're learning how to use Gradle Enterprise, but you're also getting a better build out of it at the same time. And one of the big things is maximizing caching. So maximizing cache hits. A lot of builds, if you're just running vanilla Gradle, you'll probably get a good hit rate. But as soon as you start having custom code, custom plugins, that sort of thing, it's really easy to have a slightly misconfigured build that'll cause you to have cache misses. And even a team like AndroidX, which I have to admit, it was really fun working on an open source project because I could actually see the code. Those guys had worked really hard at maximizing their cache usage, and it was already working well. But we still use Gradle Enterprise to find some things. So what we do is we run these things called experiments. And really it's just what you would do locally. You go, okay, run a clean build, and now run a not clean build. Let's just run the build again without clean. Let's make sure everything's up to date. Let's just not, if anything's running again, why is it running again? Why isn't it up to date in Gradle? And there's sometimes good reasons for it, but usually it's because we just haven't declared the correct inputs for it, haven't declared the outputs for that task. So we basically go and fix that. We have the similar things for caching. We'll say, okay, let's run a clean build and another clean build in a different location on the same machine. Let's make sure that we get 100% cache hits for the cacheable tasks for that build. And this is an example of something we found in the AndroidX build. There was ones that were running, they were getting cache hits if they ran from the same location. But as soon as they ran from another location, they didn't. And that's because there's a path sensitivity on every input in Gradle. And if you have absolute path sensitivity, then obviously Gradle goes, well, actually, that's a different file. It's from a different location on the file system. So therefore, I can't use that. It generates a different cache key. So that involved, okay, cool. It's a pretty easy fix. We just go and add a path sensitivity relative to the particular task input and then run the experiment again. Sure enough, we get another cache hit. So we sort of ran through these experiments. And what we've done recently is we've built, and that's the link you can see on the screen right now, is we've automated a lot of this experiment running. So people can download this tool. It's a bash-based tool that'll basically automate the execution of all these scripts. Now, Gradle Enterprise is not running the scripts, and it's basically Gradle Enterprise is helping you analyze the results. So it basically allows you to do build scan comparisons. So that's something we haven't shown in this, but basically you can get a build scan from two different builds, and it'll show you all the task input differences for a particular task. So that's how we might have identified for this particular SDK resource generator task. It actually had, this file is different. It's because it's an absolute path. Cool, I know how to fix that. So it really helps you zoom right in on what's causing these cache misses and helps us speed things up by getting cache hits.
Yeah, I was actually going to jump in and actually share it directly from the Gradle Enterprise so we can kind of see all the stuff that Daz just talked about. So let me jump in on that.
In the meantime, and I know people they can actually look at this in the portal, but what is the current build time right now on average for AndroidX? That's one of the questions.
Well, it's a trick question because there's no one answer. Like, we have many projects, so it depends. I think what we found is when we hit the no-op build, it is currently 2 minutes on Github Actions, which could it be better? Yes. But I think it's actually fairly good given that we're running on like 3 threads and like a fairly low-powered machine on GitHub Actions. But essentially, our no-op builds in the past have been more than 2 minutes. Now, most of our builds, when I was showing the graph, you probably saw that it was, most of the things are just no-ops because we have so many projects. So most of the changes actually only affect a single project. So instead of, going us and rebuilding stuff over and over again and, wasting time, we're having a fairly efficient use of GitHub Actions. Yeah, that's the trick question. Internally, I believe I was looking it up. I think now our builds internally are for all of our projects where we build it as like a monolith. And this is building on, I think, 128 core machines. It takes around 30 minutes. So we're in like very, this is for a clean build. It's a very beefy project. Like I think last time, if you look at serial execution, it's something close to I think 24 hours, I believe, worth of work that ended up running in 30 minutes because it is able to parallelize. And actually, we can probably pull up some of these scans if people want to, jaw drop a little bit of how much work sometimes you can do. And Gradle Enterprise obviously handles even a scan that has that many, tasks and that many executions. So anyway, I was going to jump in here to kind of show how we found the specific SDK generator project. So this is one of the tasks that is used as an input to some JVM tests that we run in AndroidX. And what it was doing, it was generating some specific inputs that we needed to run. It needed some prerequisites. It needed some additional values. And some of those values were paths. And the tricky thing with Gradle paths is, for historical reasons, Gradle by default assumes that any file input has an absolute path sensitivity. And that is, a big FUD-con. So I think what if I was going to have one takeaway message is like, anytime you have any file input anywhere in your custom tasks, go ahead and look and see what sensitivity you actually want on it. So what we ended up doing is actually from, having absolute paths for our tasks, replacing them with a lot of relative paths. And what that does, it allows us to do a lot of this stuff in a more effective way. So this one is actually just passing strings. So it's not entirely kind of like on Gradle. This one was on us. Why were we passing absolute paths? Good question. I didn't know any better is really the answer. But the same is true for any task. So by default, if you have an input directory, Gradle will assume that absolute path is necessary for that input. Because that's the safe way to kind of like if Gradle went to change the default, then it would break thousands of builds for everyone. So it's obviously not a safe change. But for someone who owns your own tasks, I feel like there's probably not a good reason not to have path sensitivity on any of your file inputs. So that's the kind of thing actually we've been looking on our own team to like how do we build ourselves some like linters to make sure we don't miss this kind of stuff. But essentially, it's important to kind of figure out like do you really care where this file lives? For example, in most of cases for us, it really doesn't matter what the path of the file is. We really care about the contents. And if contents haven't changed, there is no reason to rerun the tasks. And as Daz was saying, like if we set it up, we have like nice inputs and outputs, but we're missing sensitivity. Locally, you will never really catch this unless you moved your project directory from, one part of your, drive to another. And then you will be like not hitting a cache. And it's actually one of the experiments in the script that Daz's script runs is, it runs a build in one place, it moves it over and then runs it again. And in theory, you should be getting 100% cache hits. But, in our case, we were not. And that's, kind of how we caught this issue.
Yeah, my understanding is also Gradle, this is already missing these annotations on a cacheable task is already deprecated and it'll be a failure in Gradle 8. So the linter won't be required because it'll actually be just a straight up, you have to if you want a cacheable task, you have to tell us the task sensitivity of all your inputs.
And Aurimas, earlier you mentioned, hey, when you first started doing this, you all started using build scans and just setting up your own remote cache backend. And how was that experience versus this? Would you, when you were how deep could you go with what you had versus the workflow now?
So I think Gradle cache nodes will get you all of the benefits of actual caching. Like it is, the tool that will, essentially enable a shared cache for your team. So, if you have a CI seeding it and everyone else getting the values from it, like that is, that part, Gradle Enterprise doesn't really add too much outside of that. You now have like better UI to see what's going on with your cache. The part that is kind of like novel and new is being able to kind of track stuff over time. So compare to builds or see how the trends are or see, what are the common failures that people are having. So I think that part was kind of missing from being able to just use --scan and then using a custom instance of a Gradle cache node. So Enterprise kind of like adds like a layer of, very useful, nice things is probably the best way to succinctly put it together.
We have a couple more questions.
Let's lead into some of those. This one's kind of good, actually. I think it's a pretty good question to follow up what you were just talking about, because we've been focused a lot on improvement of the build times through the caching and everything like that. But apart from the build times, what were some of the maybe the most challenging issue is how the question is read. What is the most challenging issue that AndroidX devs face to try to improve the productivity beyond just the build speed time?
That's such a wide open question. I don't know. What is the hardest thing? It really varies, right? I think the time that my team spends the most, that is like the most difficult, I think is anything that's flaky, anything that's not deterministic. So for the past probably 8 months, we've been chasing a flake in Kotlin Gradle plugin. There was a case where it would sometimes not build correctly incrementally. It would be losing some of the data. And there was a bug essentially in the way they was being initialized. And then sometimes would like switch between incremental and non-incremental modes. And it was really, really difficult because it was failing like 1 in 100 builds in CI, and like locally would almost never be able to hit it because CI runs on much beefier machines and it like runs everything. So I think that's the kind of stuff that's really difficult to debug, because, a failed build and someone's, pre-submit being blocked is really big deterrent, because they have to go in and run it again. And then, they lose faith in like the CI and CI being good. So like kind of like making sure that, stuff is stable and works correctly. It's I think those are the difficult ones. And I think especially because our build is so complex, I think it makes it, another level of debugging. When I want to make a reproduction case for Gradle or JetBrains, we end up spending, an hour of like building a smaller project that also can hit the exact same problems.
In our ebook on DPE, we call flaky test the infinite pit of sorrow. I think I can relate to that. Yeah. So this is an interesting question too, and answer. However, kind of in this investigation, Daz, Aurimas, did you come across issues in the Android Gradle plugin, or even in Gradle, that were addressed as part of this as part of this partnership?
Let me think. I think we definitely had some improvements for Gradle that we wanted to suggest. I think on our side, I think we ended up seeing a bunch of things that are just now easier to see, that before we were kind of like just sliding under a rug because it was not very much in our face. So I think that's that type of angle that we're kind of coming from. Is like, why is this task marked not cacheable? So like we went to AGP and we're like, you marked this not cacheable on purpose. Like why? Right. And that I think starts very different kind of conversations, because then you're able to, I have the data now. I have a scan. Like, look, this task is in fact taking a long time. Like, would it make sense for us to cache it? And then we can kind of debate, like, for people on low network conditions, is actually a bad idea to cache it, because now you're downloading 300 megabytes, but we're living on this network that is, amazing speeds. So for us, cacheable is actually worth it. But for an average developer, it's not. And then we can have like the discussion and debate. And then I think that's the kind of evolution that we can do. And I guess, Daz, maybe you can jump in and say some of the stuff you found.
Yeah. So we work pretty closely with an Android Gradle plugin team to improve cacheability of all of the Android tasks. But usually there's a lag there, right? So Gradle actually has an open source plugin called the Android Gradle Cache Fix plugin, which will basically monkey patch your tasks to actually make them cacheable if you're using a version of Android Gradle plugin that hasn't yet adopted these changes. So there's quite a lot of stuff that we've sort of said, like, for example, we found that this task doesn't make sense to cache, but Android 4. something marked it as cacheable. We basically unmark it as cacheable through this Android Gradle Cache Fix plugin, and then AGP 7 has then taken that and made it live. So that's an example of something that we haven't applied that Cache Fix plugin in the Android X, because Android X is always using the latest version of AGP. We have also shown there are some things that we haven't yet fixed. So there's I think it's the room support in AGP. There's some way the annotation processes work that prevent us from making these particular tasks cacheable. And so that's something, in some ways, what we've done is we've made this more visible to the Android X team, because we knew about it. Our customers knew about it, but internally, because those guys were building, that sort of monolithic. I'm not quite sure why, but basically now that we have build scans, we basically be able to make this stuff. The room builds are a bit slower, and it's because you're not getting cache hits on these particular tasks. So that's an example of something in AGP and in Android X that I don't know if we discovered that it was broken, that it could be improved, but we certainly made it more obvious and increased our shared understanding of what these problems are. And we're actively working on the room fix right now. So
super interesting. And then this last question that's still in the bank. This one could be like a whole topic. So maybe if anything just kind of comes to mind immediately, we could. And then if there's thoughts, we can always follow it up in the Slack. But having so many repositories for Android X specifically, is there a Gradle feature or some other tool that you're using or that you recommend to try to keep all of your repos up to date with your dependencies in a way that's highly deterministic?
And I want to add one more to that as well, right? You all had to turn on and enable and watch the remote cache for so many projects. How did you solve that problem?
That scale across so many different repositories. Was that, and I think that the question is actually really a technology question. It's like, did you use something? Was there a technology that you used?
Well, I think, I'll jump in a little bit, and I think Daz can amend and add. I think it is true that I think we are, I think large projects in general have sometimes a slightly different set of problems than small projects do, because some things are not that expensive, so you can ignore it. I think like an example is like configuration caching, configuration caching and just configuration time. When you have a small project, it really doesn't matter that much if it's taking 1 second per project to configure. Imagine that would be on AndroidX, and then you have 300 projects, and it takes 1 second per project. Now you're configuring for 300 seconds, which is an unacceptable amount of time to do any task, right? And like for us, something like configuration caching is vital. Like we wouldn't want to have time spent on every command. And for folks who haven't looked in configuration caching, highly recommend. Definitely want to enable it. It's an amazing feature. So that's the kind of an example of like where it's different, right? From a small project to a large, we really had to spend a lot of time to make sure we're configuration cache compatible, and that we're actually spending a small amount of time, doing all these kind of configurations. And I think there's kind of like other angles. For example, like GitHub Actions gives us a very limited budget of how much data we can store and restore. And I think Daz can talk a little bit more of like how do we went about that part.
Yeah, just to step back to the specific question, the AndroidX is a very interesting case, because it's not the case where we have lots of repositories with separate Gradle builds that are sharing outputs. What we have is a monorepo with all of AndroidX in it, and then we have sub-projects within that have been set up as independent Gradle builds. And I haven't seen this done before, so it's really interesting. So you'll see settings.gradle files in these sub-projects, so you can run Gradle from within them as though they're independent. So the problem of keeping dependencies updated between them isn't there, because you're really effectively building within a monorepo, even though you've got multiple Gradle builds within there. All the logic that shares that makes sure that they all use the same Gradle Enterprise configuration, the same build source setup. That's all up in the build source, or actually there's a playground common module or something project. Yeah. So and that part of it, and we sort of improved that as part of this trial process. But yeah, so it's not the classic problem of I've got hundreds of repositories and I need to keep all my downstream dependencies updated when I release a new version of a particular library. Regarding the GitHub Actions cache limitation, we did have to, because we have 10 playground projects or 9 playground projects. So each of those is a separate Gradle build. Because they're running the same GitHub repository, they share a common, I think it's now a 10 gigabyte limit on storage for GitHub Actions caching. So this is a case where I think Aurimas showed there's a couple of them took a long time to run. It's probably what's happened is their Gradle user home cache entry had been evicted prior to those running, so therefore they reran. But we did have to do things like exclude certain directories from Gradle user home from the GitHub Actions cache, just to avoid these things blowing up. And one thing the Gradle build action does is in the post action, you can actually see exactly what cache entries were saved and how big they were, which is really interesting, because usually GitHub Actions caching is very opaque. It's really hard to see what's going on in there. But we added some the Gradle build action adds some inspection points, and actually we had to patch the actual Actions cache library in order to get the size of entries that we were creating. But it's really useful value. So as you can see, all of the different entries that have been uploaded, and we've tried to maximize usage by sharing things that are common between lots of builds. We try to only cache them once. So we extract the generated Gradle jars so that we only save them once across all of these separate builds.
Yeah, and I think this kind of sparked for me, like Daz talking, one thing that it kind of makes sense also for large projects. I think version catalogs, which were kind of mentioned earlier, are the really useful way for us to kind of share the dependencies that we use. So actually, we share the same library versions TOML file across all of the repositories. Gradle has APIs in settings.gradle to specify where your version catalog is. So if you have many different projects, you can actually have all of them point to a single TOML file. You don't actually have to have one per thing, and you don't need to symlink or anything like that. You can just say, this is the canonical one. And, if you have many repositories, you could even have a repository that only holds the TOML file, and then everyone has that as, a Git submodule or something like that. So that would be a way to kind of go about on the dependency sharing.
And we are out of time. Any other questions we can take in that Slack channel? Aurimas, thanks again for coming here and sharing your stories with us and helping the community with some of your wins and findings. And folks can, all of our kind of links are in here, and the QR codes are in here. And Aurimas, anything you want to share with the community in general before we go?
Yeah, I mean, I think Gradle community is pretty awesome. I think we gotta keep pushing things and making things better. I think don't be shy in filing bugs to Gradle. I've worked with people personally now, and I know that they want to fix things. So don't shy away from if something doesn't make sense, go and file an issue on GitHub or for Gradle or AGP or AndroidX. I think all of the folks want to fix it. Sometimes the fixes take longer than you'd want because we're too busy. We're drowning in all the exciting things. But I think that's one takeaway is care for your builds. Build matters, and we want to make sure that builds are done well, and make sure that you don't waste your engineering time. That's probably the wrap.